say this dataset is famous because since 1984, when I published it in my book Theory and Applications of Correspondence Analysis, it has been used as a test example in many software packages, for example SPSS and Stata. Another curiosity about these data is that they are artificial, yet some statisticians have analyzed them as if they are real. But I can assure you this is a carefully constructed table that I made up to illustrate the basic concepts of correspondence analysis. As I said in my book, I invented this company doing a survey of its staff to decide on its smoking policy. So a survey of all 193 staff members was made, and this cross-tabulation is one of the results of the survey. The rows are a classification of the staff in terms of their position in the company: senior managers, junior managers, senior employees, junior employees, and secretaries. While the columns are a classification of them as non-smokers, light, medium, or heavy smokers according to their smoking habits. For example, in the first row, there are 11 senior managers, of whom 4 are non-smokers, 2 are light smokers, and so on. Now, thanks to the use of dynamic graphics, I can explain the basic geometry of correspondence analysis in 1 minute, which is what I will do now. First, let's omit the non-smoking column and consider the simpler problem of the 3 smoking categories only. Each row of 3 counts is expressed relative to its total, giving positions of the staff groups in 3 dimensions. But because the 3 coordinates always add up to 1, they lie in a 2-dimensional triangle joining points representing the 3 smoking types. Already in this triangle we can see that junior and senior managers have a tendency towards heavy smoking. Now let's consider the original matrix including the non-smokers, again expressing each row relative to its total. The staff groups now lie exactly in a 3-dimensional space within a tetrahedron. The 3 black lines at the center are what correspondence analysis calculates, called principal axes, allowing us to display all points with respect to the best 2 principal axes, omitting the least interesting one in this case. Finally, there are several scaling options for the best 2-dimensional plot. This shows one where the row and column points are spread out similarly along the respective principal axes, making it easier to label the points. Well, that's it. I hope you got the basic idea of this data visualization method. To read more, see my book Correspondence Analysis in Practice in its 2nd edition, or the translation into Spanish. The Spanish edition and my book Biplots in Practice, which also contains material on correspondence analysis, can be downloaded for free from this website, multivariatestatistics.org, thanks to the BBVA Foundation in Madrid.